Hi, welcome to another Animation Notes in Blender 2.8 tutorial. In this video, we will take the memory concept from the last video to a whole new level. If you haven't seen the previous video, you might want to watch it before watching this one. I will also put a link to the playlist of my entire Animation Notes series in the description. Here we are going to create this kind of animation where we use the audio spectrum data to position vertices and then shift that spectrum information down the mesh over time. Let's get right in. Here I am, again, Blender 2.8 beta still. First thing, just delete everything. Now the only object that I need to do this effect is a mesh grid. And I will set the X subdivisions to 20 and the Y subdivisions to 100. So when I go into edit mode, I get this mesh and I scale it by hitting S on the Y-axis 5 times. And now I have nice squares. And this mesh now has 2000 vertices. And that's pretty much all I need to do for the geometry of my model here. I can go right into animation nodes and create a new node tree. And first off, I'm just going to switch off auto execution altogether, because I need to set up the node tree first and I don't want it messing up my mesh. Okay, now let's look at this mesh quick. Like I said, we have 2000 vertices and I'm going to use an audio file, some music, to modify only this first row of 20 vertices here. So this tutorial is not really about video editing or doing anything with audio, but it's a quick and easy way to get some random interesting looking things. Okay, just use this file. And just like in the last video, in our node tree, we need sound from sequence. Eyedropper that in. That's that MP3 file. And then sound spectrum. Plug that in, take the animation time info and plug it into the frame. Here I'm going to set the amplitude to 2. Here we have 20 sound spectrum slots. So here we have a list of 20 double values. And I will use those to modify those first 20 vertices. Okay, now let's get those vertices. First, we need a mesh input. And we're going to use this grid object that we created here. In order to rip this mesh information apart into vertices, edges, and faces, we need the mesh info node. And I don't understand or know why it isn't in this mesh menu here, because it's a very useful node. But we can always hit Ctrl A and search for it, mesh info. And here you can see we can plug in a mesh and then we get vertices, edges, and the faces basically. Now here, this is a list of vertices. And the way this is set up when you create a mesh object is, this is the first vertex, this is the second one. So this one is index 0, this is index 1, 2, 3, all the way to index 19. And then this one is 20, 21, 22. Okay, so we need the first 20 vertices out of this list here. So list, slice, plug in this, length start at 0, length 20. And now we can plug this output and this output into our loop. So let's create a loop, subprogram loop. I'm just going to call it spectrum, because that's what this loop does. It takes an iterator of a float list and a vector list. Over here we can invoke this subprogram. Plug the spectrum into the float and those 20 vectors into the vector list. And now in this very easy loop down here, we simply take the vector, separate it into x, y, z, take vector combine the x, the y, and for the c we use the spectrum information, the audio information. And this loop should output a vector list with the modified vector positions. Okay. So here we plug in the first 20 vertices, which is those 20. Then we use the sound to modify the x-axis of those. And the output here is a vector list. And to plug those back into our grid mesh, we have to use a mesh combine. Where are you? Combine mesh those vectors. Well, actually not those vectors, but those edges and those faces. Now we have a bit of a problem because the output here is only the first 20 vertices. And if we plug that in here, our mesh is only going to be 20 vertices. So we need to combine those first 20 vertices with all the other vertices somehow. We can simply do that by copying this slice. We start at position 20 and take 1980 vertices. So these are all those back here. And we can do list combine vector. First the first 20 vertices, then the other 1980 vertices. And now we have our complete vertex list again. Okay, now we need to plug this mesh data back into the object. Mesh object output. Plug the mesh in, enable it, and we use this same grid object here. So we take the mesh from the grid, we change it, create a new mesh, and plug that back into this grid object. Okay, that's basically everything we have to do to get the audio information. I'm going to save the file and switch on auto execution for frame change. Now let's see what that looks like and if it works. And you can see it does exactly what we wanted. We're changing the first 20 vertices. Now one thing that I've noticed in the last video too is that the sound spectrum node gives us a lot of amplitude in the lower frequencies, but basically nothing in those higher frequencies. And a simple way to just get something that looks more interesting is to not use 20 sound spectrum slots, but something like 60. And then only slice out the first 20 of those 60, so we get more detail from the lower frequencies, right? See, now we moved it over to the right a little. Okay, that's the first part done. That wasn't too hard. Now, let's get to the interesting part where we take this information from those 20 vertices and over time push it back on the y-axis while the music is playing. So how do we do that? Well, we already have this slice of vertices here, which are basically all the vertices except for that first row. And we can create another loop to copy the C information, the C value, height value, from this row to this row, and then from this row to this row. But we can't do it from front to back, because if we copy the C value to this row and then this C value to this row, it's all just going to be the same. We actually have to start in the back. Okay, and we are going to plug that loop, another loop, right in here. So we will work on all of the vertices to copy that information. Let's create another subprogram loop. I'm going to put that down here somewhere. I'll call it, let's call it shift, because we're going to shift the information back. And all we really need is a parameter containing all of the vertices. So parameter vertex or vector list. We're not going to use an iterator for this because we want to access all of them. Okay, now we can invoke this loop, subprogram invoke shift. We take this vector list right here and we want 1999 iterations. And then the output of this subprogram is going to go in here. But for that output we have to do something special. And we'll see that very soon. So, like I said before, we have to start in the back. And this index starts at 0. So it starts in the front. Now there's an easy way to switch that around. Just number, math node. We subtract from, oops, sorry. We want 1980 iterations, right? So every vertex except for the first row. And right here, we actually want to subtract the index from 1999. This node right here has index 1999. We subtract 0. So the first index that we're actually handling is this one. And then this is the second one, the third one that we're going to handle inside of this loop. Okay, now what do we want to do? We want to get a list element from our vector list. From this vector list, we're going to get this element, so this vector or this vertex. We're going to vector separate it into x, y, and z. We keep the x and the y because it should stay right here, but we want to change the c. And what do we want to change the c to? Well, this vertex should get the c location of this vertex. So we want to get another list element from this list. And we have to subtract 20 from the index. And that's the index for this getList node. Right, so this is this vertex now. Again, we separate this vector. Can switch off this wrap too, because we don't need it. And all we have to do is combine this vector. So we keep the x here, we keep the y here, and we take the c from this one. And then what do we want to do with this new vector? We want to set it into our list. So this vector list gets a new vector at which location? Well, this one. So this index here. Now this loop is going to go through each and every vertex of this mesh and copy the C information from the previous row here. And up here I said I want to invoke this subprogram 1980 times. But I don't want to invoke it 1980 times on the same vector list. I want to use the resulting vector list here to plug it back into the front here for each and every one of those 1980 iterations. And there is a way to do this in animation nodes. You select your loop input. You go to the Advanced Node Settings over here, and you click Reassign button and place this reassign loop parameter node. You can plug the list in here. And now what that does is it takes this vector list, modifies it for the first iteration, and uses that output, the modified output, plugs it back in here for the second iteration and for the third and for the fourth. So we're working on this basically on one list of vectors, but we change it 1980 times. Okay. And I also go here and enable output, which gives me, which gives me this vector list output slot here on the invoke subprogram node. And now I can plug that in here. So just a quick recap. We take all of the vertices from our grid mesh. We shift the C information from this row to this row, and from this row to this row, and from this row to this row, and so on and so forth, all the way to the front, which means our audio information that we have in the first row of vertices gets pushed down the line on the y-axis. Okay, let me go back, save this file. Go out of edit mode because otherwise we get this error message here. Now let's see what that looks like. Okay, that is not working the way it is supposed to. So let's see how we can figure out what is wrong. So let's see. Let's put in a loop viewer, plug in this index, create a new output, and view it over here. Right, so index goes from 0 to 1979, that's correct. So this one goes from 1999 to 20, going from the back to the front. Here we get a list element. We separate that x, y. Okay. Oh, of course, I have to use this vertex and subtract 20. Okay, here we go. Now we have the spectrum information moving towards the back. Okay. Well, this is already working nicely. Now one other thing we can do here is, instead of using the C information here, we could make it shrink down a little while it's moving towards the back. So number, math, plug that in here, multiply by 0.97 or something. Play. See, now it all shrinks down when it moves towards the back. Actually shrinks quite fast, I have to say, so 0.99. Okay, this looks cool. One other thing you can see here, I have auto execution frame change enabled. So I can go backwards or forwards every time a frame change occurs. The data is moved towards the back. Okay, so no matter what we do, we always have audio information on this grid now. Now there's an easy way to fix it. We can go up here, set the amplitude to 0, and hit play. So now we're just filling it all with zeros. Once that is filled, we can go back, set the amplitude to 2, and then we start with a sort of a blank grid here. press play, and here we have that effect. Cool. Now, the rest is all just materials, lighting, camera. What I did for some of my final renders is also I put a subdivision surface modifier onto this mesh. View 2, hit W, shade smooth, and then you get those very smooth mountains. Almost looks like a landscape. Right, now you can look at it from this side, which looks cool. Oh, sorry. If you hit W shade smooth, it only shows once in the viewport, and as soon as you hit play, it's flat again. And that is because we're creating a new mesh and putting it into this grid. And in order to get it smooth, we actually have to smooth this object every time this node tree gets executed. So we just hit Control A, smooth, shade object smooth, and plug it in here. And now you can switch on smooth, hit play, and we get a smooth surface. Now let's do maybe a little bit of shading. So go to the shader editor. On our grid object, I go to, well, maybe I split it, go to rendered view, switch off overlays, turn the world to black. Then maybe add a wireframe modifier to this. Turn down the subdivisions, so it looks like this. Turn down the thickness of the wireframe. So now I also give it a new material, make it an emission shader. So we have this, which looks pretty cool. I might also go to the wireframe modifier and switch off replace original. So we have the original faces and the wireframe. Then we can set the material offset to 1. And now we can add another material, move that up. So this is the material for the faces now. I'm just gonna do something like dark gray. Okay, now, just like in the last video, maybe we go to this material, the emission. Again, we take the geometry information, convert, separate X, Y, Z, convert our color ramp, plug the C in here, plug this into the emission color, make this one white, and make this one red, for example. Okay, again we are going to need a converter math in here, set to multiply. We can bring in the red a little more. So now it looks like this. Okay, well, you get the idea. There's plenty of things we can do now with lighting and shading to get nice looking results, like these ones. Okay, a quick recap. Let's go to animation notes. node tree and look at what we've done here. So we used the music sound spectrum, the lower frequencies, that's what this slice is for. And we take the first 20 vertices of our grid mesh and use the sound spectrum information to move the C location up and down. That's this very simple loop here. Then we take all of the vertices with this loop, which is the green one down here, move the C information from the previous row of vertices to the next row of vertices. That's what this does. And we take that list of vertices and this list of vertices, combine it back together into a list, create a new mesh out of these vertex locations, reuse the edges and the faces so that our mesh has edges and faces, create a new mesh object inside of that same grid object in Blender, and then this is just to shady smooth, and this is our node tree, which gives us this moving sound spectrum effect. Alrighty then, if you enjoy what you see, please smash that like button, subscribe to my channel and activate the notification bell. Check out my other videos on Blender, cycles, Eevee and animation nodes, and don't forget you can download a current build of animation nodes for Blender 2.8 from this address. Thanks for watching, have a good one, see you soon.